Guys, hope you are fine. Welcome back to my YouTube channel. And today guys, we are going to look at a bit of statistics. So guys, we are going to look at this table. And let me just read the question. Table 1 represents the frequency distribution of length of 150 components in centimeters, cut off by an automatic guillotine machine. Determine the we are determining the mode, interquartile range, and then quatile deviation. So guys, I have done some work here for you, and this is where I have gone ahead and calculated the cumulative frequency. And as you know guys, it's quite easy to do that because you just go ahead and add. First of all, you write 8, then you add 8 plus 26, you write there 34. Then 34 plus 30, you write 64. 64 plus 45, you write 109. 109 plus 20, 129. And finally, 129 plus 17, 146. 146 plus 4, then it's 150. So guys, and you know that one, you have to look at it because here you have been told the components are 150. So this one must total to 150. So this is what we call cumulative frequency. And now guys, we go now to the question direct. We are asked to determine the mode. For us to determine the mode, we need to identify the model class. And the model class is the one that has the highest frequency. I've already identified it for you because here we have, if you look at these numbers, what is the highest number or which is the highest number? It is 45. So our model class is 45 to 60. And so guys, after identifying the model class, we come now and use now this equation to find the mode. And this is the equation we use. And after I write the equation, I'll show you now guys how we can be able now to understand about that equation. So the mode is given by L, which is the lower class limit of the model class. And the model class we have identified it is this. That is the model class. The lower class limit is supposed to be 45. Because guys, if you look at these classes, you can see we have 60 here, 60 again. So we may not do as we would do others, whereby if we had 60 here and here we had 61, then we would have said 60.5. So this one now remains our lower class limit, and that is L. Now this one you add into bracket, open the bracket, D1, whereby D1 is the difference between the frequency of the class before the model class. The difference between these two frequencies, that is the frequency of the model class and the frequency of the class before the model class, that is the D1. All over that D1 plus now D2. For D2, guys, this is the difference in the frequency of the class after the model class, and that class is 20. So now guys, you take away 45 minus 20, and the other one, for D1, you take away 45 minus 30. Then from there guys, you come and multiply by the class interval. So guys, let me show you in a graphical form of what I mean. So guys, I have drawn a histogram for you. And so I have drawn it to explain to you about this. So guys, we have what we are calling the lower limit. And the lower limit is at this point. At this point, guys, we have our 45. And that 45, you can see it here, guys. Can bring it closer. This is now our 45, the lower limit of the model class. And then, guys, from there, and that's what I will write here, we have the L and then plus. So when we come here, guys, the difference between the model class and the class before, this is now the difference. This is now what we are calling D1. Now that's why that is 46 minus 45 minus 30. That is our D1. Coming now to D2. For D2, we are going to have the difference in frequency of the model class and the class just after. And this one now is going to be D2. And that's what we have done here, guys. And then we have the class interval. Class interval is from this point to this point, of which for us, we are going to have it being 15. This is the class interval. From here to here, we have 15. And as you can see, guys, we have these class intervals they are what we call exclusive. And so for exclusive, we use the upper limit and the lower limit, which is now for us is 60 and 45. That gives us what we 15. And so, guys, we have now 15 as our class interval. So here, guys, we come but before we continue, let me continue to explain about this graph. The point we are looking for, guys, is just around here. Around here is our mode. And that point we can find it by calculation. But for approximation, that point can be found by joining this point to that point, and then you also join this point to that point, like that. When you join that point, guys, then you come and now draw a line like this. So whenever that line will touch at this point, that will be our point. Guys, I'm not saying it is at the center, because this is just a graph of which it is not exact, but it's allowed between that point. This is our midpoint, and it is not that it is at the midpoint, it's just allowed that area. And so, guys, we come now and calculate and see the exact value we are going to have. So I will now put my 45 as my lower limit of the model class. So let me write this one as 40, 45, like that. Plus, now we come to D1. The difference in this, that is the model class at the lower limit, and that is the difference in frequency of the class before the model class. So this is 45 minus 30. 45 minus 30, that is 15. All over 15. Now plus the difference between the model class frequency and the frequency of the class after. So this one is going to be 45 minus 20, which now gives us 25. Now we multiply by the class interval. For the class interval, guys, we are going to have it as 15. This is 15. That is the difference between the upper limit and the lower limit. And so, guys, we calculate that. Maybe you calculate it at this point. So we have 45 plus now 15 all over 40. If we do that, we shall find 15 divided by 40 that gives us 0.375. We multiply that by 15. So if we multiply that by 15, we shall have times 15. This one gives us 5.625. 5.625, like that. And so guys, our mode then is going to be 45 plus 5.625. That one comes to 50.625. So guys, that is our mode. So guys, that is the solution for that. And now guys, I would like you to follow me in my next video so that now we can be able to calculate the interquartile range and quartile deviation. So guys, welcome to the next video. Bye bye.